Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where it's hopefully just in time for you. My students are just getting ready to start doing some AP statistics review. And so that's what we're going to focus on tonight is the AP stats exam and how we can maximize their scores using TI technology. My name is Mike Houston, and I'm the moderator for this event. Tonight we're joined by Darren Starnes and Tracy Watson. Darren's taught AP stats for 25 years and has been an AP exam reader for over 20. He started teaching math in 1990 with the newly released TI-81 graphing calculator and then quickly realized the power of handheld technology to promote student learning. Darren became a T-Cube instructor in the early 2000s, and his current focus is on using TI technology to develop an understanding of margin of error and p-value. So Darren, it's great to have you with us.
Thanks, Mike.
And Tracy has been a teacher at the high school and college levels for over 20 years. She's currently an assistant professor of instruction at Ohio University and mathematics specialist at the Arkansas School for Mathematics, Sciences, and the Arts, focusing on AP statistics support for teachers across the state of Arkansas. She was introduced to the graphing calculator as a teaching assistant in graduate school at Ohio University and hasn't turned back. As a T-Cube national instructor, she enjoys sharing with teachers across the country the appropriate use of technology. And the good news is that this year will be her sixth year as an AP statistics reader. So, Tracy, it's great to have you with us.
Thanks, Mike. Appreciate you being here.
And Tracy, just keep on going. Talk about our agenda for tonight.
All right, tonight we've already done the welcome and the introduction, so we're real excited to get into exploring the TI technology that we have in our students' hands to answer actual AP exam questions, multiple choice and free response questions. And we're going to focus on three major content areas: exploring data, probability random variables and sampling distributions, and inference. At the very end of the webinar, you want to stay tuned because we're going to have a one slide that will share a bunch of resources to help you review for the AP exam. And then, of course, you definitely want to hang around for the webinar drawing.
Thanks, Tracy. And Darren is going to discuss our expected outcomes.
So there are three outcomes for the session today. First, that you can use normal, binomial, and geometric probability distributions on the TI-84 or the TI-Nspire to calculate probabilities on the AP statistics exam. Hopefully that I also means your students can. Second, that you can use the stat tests on the TI-84 or confidence intervals and stat tests on the Nspire to perform inference calculations on the AP statistics exam, both multiple choice and free response. And third, that you can advise students about what work to show when using technology on AP statistics exam free response questions about probability distributions and inference.
Awesome. Thanks so much, Darren. Tonight, we'll be using that chat window to send general messages. And if you have any questions for Tracy or Darren, go ahead and use that Q&A window on the lower right side of your screen. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So, Tracy, it is all yours.
All right, thank you. I hope that you're seeing my screen now. And one of the things that I'm going to put in the chat right away, as long as I get my chat window right away, in the lower left of this slide, you'll see a tiny URL that you can grab from the chat. And that is a Google folder that has this slide presentation, has a handout of the questions that we're looking at that you might find handy, and PDFs of both of those, along with a link to a folder that you're going to want to look at later on. So Darren, do you want to give a little idea of what we're going to do with them tonight?
Well, when we were talking about how to organize tonight's webinar, we really thought, how can we have the most impact in our short time together? And Tracy gave you a little preview. We decided to go based on the CED areas that we thought would be most useful for students to have technology skills. So we're going to start with a closer look at CED units 1 and 2. Now, we won't do as many questions on exploring data. There will be a transitional one that Tracy will talk about that moves us into the next part, which is probability, random variables, and sampling distributions. There's a lot of opportunity here for students to earn some easy credit if they know how to use their technology well, and that's on both the multiple choice and free response. And finally, the whole big world of inference, the last 4 units of the course. I hope some of you are in the same place that Mike is and like almost done. That would be great. But if not, fear not. We're going to show you some things that your students would be able to use to get those easy points on the multiple choice and the free response.
Okay, so we're going to start with our agenda here that, again, you'll find in the Google Slides if you go to that tiny URL. And this actually lists the specific questions that we're going to look at along with the specific content in those content areas. And then we're going to finish at the end with just a slide of some AP Stats review ideas, a place where you can figure out how are you going to review. We've got some really good ideas for you collected in one area. So we're going to jump right into exploring data. And the question that we have for you is a multiple choice question from 2013. And so we're going to take a look at this question, and we had to decide for each question which calculator we're going to use, but it really does not matter which calculator you use. We made a decision to go with one versus the other, but in our slides, you will have screenshots available to you for both calculators. So don't stress if you get behind and aren't sure what we typed in. Hang in there. There will be a slide that has all of the screenshots on the 84, and then a slide with all the screenshots on the Nspire so that you have reference for later on. So here we go. Hang tight. So here's the first multiple choice question we chose for exploring data. And if you look at this question, the content is focusing on linear regression. And we're relating the weight of a backpack with how many books are actually inside the backpack. And so for this question, the students actually do not have to run the regression. They are given the regression output, the table, and a residual plot on the side. And so students will just need to focus on the table and the residual plot to actually answer this question. The question is asking, what is the actual weight of the backpack when there's 4 books in it? Now, for this question, we can't just ask the calculator and it's going to pop out an answer. The student has to do a little bit of work with interpreting the information they're given in this table and the residual plot. So on this question, our students need to be able to take those first 2 columns and actually write the regression equation. And I chose to write it out in words because I like focusing on what the variables are. Predicted weight equals 10.53 plus 0.53 times the number of books. And so that is pulling the information that they have in the table. So now I've got my regression equation. I'm looking at my question. I'm talking about 4 books being in my backpack. So this is where the calculator is going to come in handy because I can plug in 4 into my regression equation, but then use my calculator to actually do the arithmetic for me to calculate the predicted weight when there are 4 books in the backpack. I certainly would not want to do that by hand any day, but definitely not in test situation. So that calculator is my friend, even at this point. Now, after that, students are going to have to be very careful. This does not give us the answer. The answer is not option C, even though that's the closest value, because they want to know the actual weight. We found the predicted weight. So you want to make sure when you're getting your students to write the regression equation, they include that word predicted or put that hat on top. Okay, and remember that that's predicted. I particularly like the word predicted, so it makes it stand out. It's the predicted weight. So to get the actual weight, this is where the residual plot comes in. We look at the residual plot, we find the point that relates to 4 books. Reading off the graph, I just guesstimated it's about 2.5 residual. We don't have to be completely accurate. I know it's between 2 and 3, so I just did halfway in between. That's all that I can get from the scatter plot of the residual plot. And then the second content thing the students need to relate to get to the correct answer is knowing how the residual relates to predicted weight and actual weight. Residual is actual minus predicted. AP, they know what AP stands for, so they can remember it's actual minus predicted. Okay, so that's the only way I can remember it. And then plugging our values in, 2.5 and the actual we found, or the predicted we found, the 12.65, we will just add 2.5. And notice how I didn't type that 12.65 again. I just said add to this 12.5 to get a actual weight of 15.15. So I think my correct answer will be option D, because that's the closest one. So this is not heavy using the calculator for doing content type things. It's using it for arithmetic, but I think it's essential because I would not want to be doing that by hand. Now, as a sample of what we have in our Google Slides, if I look at the next slide, there we go. I show you the screenshot on the 84 with the question, the screenshot on an Nspire, so that's what the home screen would look on the Nspire, and then followed, just to make sure we get the right answers tonight, with the answer slide, which we agree that it is option 10 is the correct answer. Okay, so you'll have that for every question that we do tonight. Okay.
Tracy, could I say one thing as we're about to transition to your next question?
Yes,
So
please do.
I've been teaching this course long enough that I can remember when students being able to type data into their lists in the calculator was actually an important skill on the exam in the early years, back in the late 90s and the early O's. That is not really the case as much now, but this is a teaser. The question coming up shows you, well, maybe a way that they could use that same skill set. If you've spent time showing your students how to input data into lists, this next one might be something that would benefit them.
Yes, nice. Little teaser for where we're headed. Someone in the chat, Rudy in the chat, says he uses RAP, residual equals actual minus predicted, to remember the order of the actual minus predicted. I like that. I like that, adding that R in there. So the RAP. Any little thing to kind of get that order straight in their head, we're going to use it. I'm going to share that with my future students, that's for sure. Okay, so our next content area is the probability, random variables, and sampling distributions. We're going to do another multiple choice question. And we chose from 1997 this exam question. And if we look at this question, it's basically talking about a company that sells calculators. They sell it wholesale and retail. And what we're trying to do is come up with their expected profit. Basically, that's what we've got here. Now, when I first looked at this question, and like Darren said, usually they're not plugging in a bunch of data into the calculator, but I'm seeing data. Even though these two tables are not individual data values listed out, we have a probability distribution for data for wholesale sales and for retail sales. So whenever I have data and I want to calculate something from it, I want to talk about what I expect to have happen. I'm going to let my calculator do calculations for me because I can give my calculator this data and get it to do some calculations for me. Now, I'm going to have to do 2 steps to get my final answer because if you notice, the question is asking about profit. And the tables are the sales, how many calculators you're selling. So the first question I'm going to answer is how many sales I expect to make. this next year based off of this probability distribution. I'm going to clear my home screen because I started a new problem. I'm going to put my data in my calculator. To do that on an 84, we go to Stat and Edit. That's where our lists are. On an Nspire, you've got that list and spreadsheet page. Go ahead, put your data in. I'm going to put my wholesale sales numbers sold in the first column, the L1. And hopefully I won't add too many zeros on any of these. And then in L2, I'm going to put what the probability is for each of those. This is a little bit different from the data that you entered early on in the course. And that one I entered wrong, caught myself. Because earlier in the course, and I did it again, there we go, we were entering data values. Well, now I have entered into my calculator a probability distribution. It's information about data. While I'm here in L3 and L4, I'll do my retail sales column, my retail sales table. And in L4, I will do their corresponding probability of each of those sales. So I've got my data in my calculator. And I want to know what sales I expect. So I'm going to take this data and I'm going to do some calculations on it. If I go to Stat and Calculate, that's where I find my one variable statistic. Now be careful, students might think to use two variables because you've got two lists that you're working on or two different tables, but the actual data we're going to work with one at a time is number sold. The probability is not another set of data. So it's a one variable statistic. Where my data is in L1, that's already there for me. This is where this frequency list comes in handy. I don't have frequencies, but I have the probabilities for each of these values in L1. So this is my L2 list. To get L2 very quickly, you hit second and then the number 2. They made it very easy to get those names of those lists up there for us. And then when we calculate, remember, we wanted to know the expected sales for the wholesale sales. And so that's what X bar is, what your average is. In this case, you can expect to sell about 9,700. I'm going to write that down real quick because now I need to do it for the retail sales also. Same thing, Stat, calculate one variable statistics, but now for L3, L4. So second 3 will change my list to L3, and second 4 will change my frequency list to that probability list for each of those values. And I calculate. And then I jot down the 890. So I've got my two expected sales from these two tables. The question, though, is about profit. And so I'm going to take each of those since I expect 9,700 from wholesale sales, and I'm going to make $20 for each of those. I'm going to multiply it by 20. And then I'll add to that, I expect 890. I did write them down, so I had them in front of me. And for each of those calculators, I expect to make $30. And then I've got my answer of the $220,700 expected profit. So I used the calculator very wisely, I think, because I had data, I put it in and used the calculator to do the calculations for the expected values for me. And it was kind of a little bit different from a probability distribution. You'll see the slides for the 84, the Nspire, and then you know what? I thought about this problem again, and you can do this one straight from the home screen, just calculators, if students know how to do expected value from a probability distribution. That did not come to me the first time I looked at the problem. That was kind of like in the middle of the night, I woke up, I'm like, I could have done it this way. But that was not my first instinct. I saw data, I put data in the calculator and did a calculation. But there is an alternate way for that one. So that's our intro into content area 2. Now I'm going to hand it over to Darren because he's got something really exciting for us.
Well, if a free response question counts as exciting, then absolutely. And I was just going to say that I had the same reaction as Tracy. I put the values into my lists right away, and then I thought later, yeah, there was another way I could do it, but I make too many typo mistakes on my home screen, so kind of like that method. I also think this would be really useful for students if there was a question about not just expected value, but also about variance or standard deviation of a discrete random variable. Students really have a difficult time with those calculations because you have to square some things, add some stuff up, and then take a big square root. And sometimes the order of operations fails. So why don't we move ahead? Let's take a look at one free response question here. This is from 2003. You can see we're going back into the past. This one's about men's shirt sizes. And for those of you who don't know, some men's shirt sizes are determined by the neck size. So suppose that men's neck sizes for this problem are approximately normally distributed with a mean of 15.7 inches and a standard deviation of 0.7 of an inch. We have a retailer that sells shirts in 4 different sizes, small, medium, large, or extra large, based on the neck size falling in a certain interval of values. So we have a 3-part question, which is very typical of probability questions on the current exam. Typically, the parts are different types of probability that students have to engage, and that makes it extra difficult because students don't easily switch from one type of probability to another. So typically part A is kind of a soft pitch. That's, I think, true here. It says using a sketch of a normal curve, illustrate the proportion of men whose shirt size is medium, and then calculate this proportion. So most students should have a good chance at that. So we're going to switch over and take a look at part A. And there's a beautiful, beautiful sketch of the normal curve. Tracy sketched that out by hand before the session.
No.
Not really, no. But students could make a quick sketch on their paper and hopefully it would look something like that because medium is between 15 inclusive up to 16 not inclusive. Honestly, it doesn't matter about the inclusive and exclusive because this is a continuous random variable. So get too caught up in that. Now, how are we going to calculate this proportion? Well, we have options. I'm of an older generation, so of course, I would hope my students would immediately calculate a z-score. So we would calculate a z-score for the upper bound of 16, and we would calculate a z-score for the lower bound of 15. And then, of course, we would get out our tables. I told you I was old. We would get out our tables and we would look up the area to the left of each of those, but then we'd have to subtract the 2 areas and get 0.5077. Now, that is how we did it back in the 1990s, at least initially. The exam was a little more focused on the traditional methods, but now we have these wonderful technology tools, and we know that we could just use a normal CDF command and get this over pretty quickly. And there are the possible normal CDF commands you might have your students use. I always made my students calculate a z-score on these normal calculations. If you're like me, then that top command is the perfect one because then the students have already standardized and they can find area between -1 and 0.429 on a standard normal distribution. But if you're very modern, I had some colleagues like this, you could just have them go straight to, let's find this area and move on and get our points. And they could write down the command that you see there. Yes, I said they can write down the command that you see there. If they write down that entire command the way that it's shown on the slide, that gets them credit for identifying the distribution, the values of interest, and the probability. That would count for full credit in the 21st century. So I would encourage the speedy way. This is a timed exam after all. So I think part A is pretty doable. Let's take a look at question from Mike. We don't have any rules about decimal places of accuracy in AP stats. That's calc and pre-calc, so we're pretty kind on that. If a student makes me, I'll say 4 places because that's what the table does. So you can see the slides here demonstrating the normal CDF process both ways. Tracy did it both ways for us. So with lower being -1 and upper being 0.429 if you're doing the standardized scores, and with lower being 15 and upper being 16 if you're doing it with the unstandardized distribution of neck size. Cool. Well, shall we plow ahead? Because I think it's going to get a little meaty here. On to part B. So part B says of 12 randomly selected customers, what's the probability that exactly 4, now as a teacher, that's like going off in my head, exactly 4 will request size M, medium, show your work. Well, some questions say to show your work and some don't, but kids have to know they're supposed to show their work whether it says that or not. The very beginning of the free response section, it says show all your work. It's nice that they reminded us. So I'm older. I'm thinking this sounds like a binomial situation because for each of the customers that we are randomly selecting, we're either going to have one that needs the size M, which I'm going to call a success, or we have one that doesn't need size M, which I'm going to call a failure for purposes of this problem. And we're going to count how many of them need size M. That sounds binomial because we're counting the number of trials, the number of successes in a fixed number of trials. We have 12 trials and we have probability of success on each trial that we calculated in the previous part, 0.5072 for the medium size of shirt. So we can look at our table and formula sheet and find the binomial probability formula, and we can plug into it. That's very much of a math teacher approach, and that's full credit. It still works. However, there is a modern technology approach that some students would find a lot quicker if they just knew to use binomial something or other. So I'm going to let Tracy go there on this one. It's in the distribution menu, second vars, and you can either scroll way down or just go up as quicker to binom PDF. Now, how do I know it's PDF? I want a particular value of the distribution, not a cumulative set of values. So the particular value we're going to plug in a minute. So choose binom PDF. Trials is 12. Probability of success on each trial is 0.5072. And X value is the number of successes we want. That's 4 for this particular problem. We'll paste that in, and presto bango, we'll have an answer. Now, if the student writes down what Tracy has on that screen, it is not full credit because it is a naked calculator command. This is being recorded, so I said naked on the webinar. We don't like naked calculator commands as work. Different calculators put the inputs in different orders, so we need to label those inputs. And as you see on the screen there, Tracy has done it correctly. We need to put basically what you saw on the previous screen, trials and the P for probability of success and the X value for number of successes. That command written down gets full credit. Now, we've gone from normal to binomial. You wonder what's coming next. Well, Tracy and I didn't like what came next on the actual question, so we made up a new part C. It says, if the retailer randomly selects one customer at a time until they find one whose shirt size is a medium, trying to get a medium sold, what is the probability that more than 5 customers must be selected? So for us as teachers, our mind is spinning like, wait, so you keep choosing one till you get something to happen. That doesn't sound like binomial. We don't know how many trials there are going to be. It could be the first person, it could be the 20th person, we don't know. So to us as teachers, hopefully this sounds like a waiting time problem or a geometric probability question. So again, we have options. We know the probability of getting a customer whose shirt size is M from the previous is 0.5072. So if we think of this new random variable, we called it Y here, is the number of customers that we have to select to find the first one with that shirt size, then Y has a geometric probability distribution with that success probability on each trial. We could, heaven forbid, calculate the probability that y is greater than 5 with an infinite series. Yeah, we don't even do that in this course, and we don't necessarily expect students would know that. So I would say let's do the complement rule. Let's at least make it easier so it's a finite series we have to find. 1 minus probability of y less than or equal to 5. And then we could do each of those individual probabilities, like probability y equals 1, probability y equals 2. You're going to get tired of me doing my old school math stuff here. Like you could do that. And then you could like hopefully not make any mistakes typing that on your calculator and get what we got. And then you eventually get an answer. Or you could say,
There
oh,
is no way
that's
I'm going to
ridiculous.
do
That's a waste of time. You only have about 12 minutes for each question on the free response. So let's just go to the technology. Now, this one is a CDF because we need the variables. The variable y could have values greater than 5. That could be 6, 7, 8, 9, 10, 11. And we're going to do 1 minus. And then I'll have Tracy go back to the distribution menu, second bars, and geometric CDF for cumulative. And we don't have a number of trials yet. We need the probability of success, which is 0.5072. And we need the X value to be 5 because we want, well, we want greater than 5, but we're doing the complement, 1 minus the probability of Y being less than or equal to 5. So much more quickly, we get 0.0291. If students write down what's on that calculator screen, they do not get full credit because they have not labeled the inputs of the command. I know I've said it twice, but just to hit it home, they've got to write what's on the slide there. And again, as Tracy said, if you are using the Nspire or you want to look back at some of the things that we're button pushing here where you're not able to keep up, we'll have those on the slides for you. So there's our first of 2 free response questions.
Now, this is one area that the Nspire, something a little bit different you can do on the Nspire that you can't do on the 84. Sorry, I lost it there. And I added a note to my Nspire slide. At the bottom, notice we can do a lower and upper. We don't have to do the complement like we had to do on the 84. So if I go look at my Nspire, we'll see a different option. If I go to menu, statistics, and distributions, and go to my geometric CDF, you'll notice I have a lower and upper bound. So this is why I don't have to do my complement on the Nspire because I'm doing it 5 or greater. And
Sorry,
I'm just going to
6 or greater, 6 or greater.
6 or greater. Oh, 6 or greater.
Yeah.
Thank you.
Yep.
And I'm just going to put a really big number in for upper bound. We don't know how long it's going to take. We just put a really big number in. And then we get the same answer. So that's the one little difference that for the Nspire, you don't have to do that complement. And that's the same thing for the binomial also. So we wanted to make sure that you notice that. Okay.
Multiple choice time.
Multiple choice time. Okay, this multiple choice question, we're still in the same content area. We've got a blind taste test that we're talking with 9 volunteers and trying to determine whether they can taste the difference between bottled water and tap water. And so if we look at this, this is a probability question. What is the probability that at least something has happened? And so the first thing that students have to recognize is that we're talking again about a binomial distribution problem because they either guessed it right or they didn't guess it right. Can they taste the difference? Can they identify that water correctly or not? So in this problem, I was thinking, okay, binomial distribution. We're talking about N trials. Now this time they don't tell me the p-value directly, and I'm not calculating anywhere, but I'm having to use that assumption they have in the question. I'm assuming that people can't taste the difference. And so that means they are, whether they think they are or not, just literally guessing. if it's tap or tap water. It's basically they're flipping a coin without flipping a coin. And so that's why the p-value in this situation will be 0.5. This problem is finding the probability that this binomial, which means the number of correct identifications, is greater than or equal to 8. Now, I still have my Nspire up, so I'm going to calculate this binomial probability using the Nspire. I'm going to go to Menu, Statistics, and Distributions again. Now, I don't want to do the binomial PDF because that would be one value, 8. I'm going to do the CDF. Number of trials, the N is 9. Probability of success is 0.5. And now notice again, since I did CDF on an Nspire, it's asking me a lower and upper bound. Now, students have to be careful here. My lower bound is 8. Now, since this is a binomial, we're only doing this 9 times, so the upper bound will be 9. It's not a really big number. Okay, I know my students would start used to doing just always a really big number when you're being greater than something. Well, no, 9 is the most successes that you can have in this situation because we've only have 9 volunteers tasting the water. And so then when we do run the calculation, we can see we can get answer B, which is 0.0195. Now, don't forget, if you're an 84 user, you do not have that ability to do the lower and upper bound. You have to do the complement rule. And make sure you notice this is 1 minus the probability is x is less than or equal to 7 is what you need to calculate on the 84 for that one. So if I come over here and just do this, distributions, do this very quickly. We're doing binomial again, CDF. The options it gives me is trials and the p-value, but it only gives me an x value. So it's looking for that 7 because it will only do from 0 up to this value for your cumulative distribution. And then notice this is a distractor because I have to do 1 minus that value. I tend to forget the 1 minus, and so I probably would have done E without paying attention with what I wrote down. The quick way to get that 0.98 number is just scroll up and hit enter. And then that does that subtraction real quick so you don't have to type all of those numbers in. Take advantage of that history in the calculator. Okay, so that, I believe, there's all the screenshots for that one, is the end of our second content area, and we're now in the inference. And so for the inference, the first question, multiple choice question we chose is this one where it's going to be talking about confidence intervals for proportions is what it's related to. We've got a marketing company and they want to estimate, they want to get a margin of error to be within a certain value. I want it to be no more than 5% if I do a 90% confidence interval. And so what they're trying to do is find the minimum number of consumers that they need in order to get this precision. So we're trying to get that margin of error piece to be a certain value, no more than 5%. So starting off this question, a student has to kind of pull that out of there because we're not calculating a confidence interval. We're only focusing on the margin of error. And so hopefully you've taught them what margin of error is and that they can write something like this down for margin of error when we're doing proportions. We're doing a 90%, so I've got Z star for 90%. Since it's proportion, it's your Z curve. The standard deviation part, I'm using my formula for my proportion standard deviation. Notice I do not have my p hat. They didn't actually take a sample, so I don't have a p hat value to put in here. So we put the worst case scenario that would make this the largest possible it could be, and that would be 0.5. So that's the worst case scenario for a p hat that we could have. Setting up the problem then, now I've done the statistics part, but now it's the students who have to do a little bit of calculator, and then I'm going to be solving an inequality. So for the statistics finish off part, I can find my Z star. This is going to be using my distributions, and I'm doing an inverse normal this time because I'm not finding area, I'm finding that number down on the bottom. And so I'm finding a Z-score. So I'm using my inverse normal command. The area I'm interested in that middle area being 90% for a 90% confidence interval. I'm doing my standard Z curve, so the mean is 0, standard deviation is 1. And the wonderful thing about the 84 is I can tell it the area I'm giving you is the center area. It's not the left tail, it's not the right tail, it's the center area. Paste that, and it gives me a Z star of 1.645. Now, really quick note, the Nspire does not do that. You can't tell it I'm giving you the center area. At least it does not do it yet. I keep asking for it. So you have to give it the left tail area for an Nspire. Since there's 10% left for both tails, half of that would be 5%. So I would have had to put the area of 0.05 in on an Nspire, but otherwise it's the same. Now this is where students can do wonderful up until this part. They're fantastic statistics students, but I've had students that were great stat students, but their algebra was not so great. And I do not want them missing this question because they can't do this algebra now to solve this. So if you have not seen this, pay attention. Both of these calculators can solve this equation for me. I'm going to put an equals there, and that's going to be good enough to get my answer. On an 84, we have an equation solver here. Under math, we go to the very bottom, so I'm going to scroll up to get to the bottom real quick. There's something called numeric solver. If you have not seen this, oh my gosh, this is awesome. This numerically solves equations. If when you open up that little program that's built in, if it does not look like this screen, make sure your calculator has the updated operating system because they've made some major changes to this some time ago. I don't even know when. And make sure your mode that you're in math print. We discovered that that's another thing that makes this look different even if you have an updated operating system. And notice it says, hey, I'm an equation solver. Give me expression 1, one side of the equation. Give me expression 2, the other side of the equation. Oops, not a double decimal. So I'm going to type in the left side of the equation. To get a fraction template, the shortcut is alpha x. Alpha x will get you your fraction template. 0.5 times 0.5. Now you have to use x. I can't use n here. On an Nspire, I can actually use the letter n. I have to use an x, so I use the xt theta key. And then on the expression 2, that's the other side of the equation. And now notice on my screen, I've got this OK button. So that's a soft key. Hit graph. Now careful, it's not done yet. The solution is not x equals 0. And if I ask it now to solve, we'll see what happens. It's going to say, nope, you're trying to divide by 0. That first x that it gives me, I'm going to hit the go to get back to the screen. That first x gives me is an initial seed for the program to numerically solve. And notice if we plug in 0, we get division by 0. So I just have to pick any other number. I'm going simple, 1. My guess is the answer is 1, even though it's not. Then I can solve, and it gives me what the numeric solution is. About, 271. That's option B. I'm done. I'm out of here. And I did not do algebra at all. I let my calculator take care of my algebra. So if you've got those students who are weak on their algebra skills, that does not stop them of doing well on the statistics test because it is not an algebra test. For those doing an Nspire, I'm just going to pull up my screen here. This is what it will look like. You do N solve, and you can just type the letters, because honestly, I don't even know where it is in the menus. I just type it and solve. You literally type the equation, and I can use n in an Nspire and then do comma n, and it'll solve it for you. So the Nspire, you don't have to give it an initial guess. It's kind of built in to try that. You could use X there too. Just make sure you do comma X. I just tended to use that. So, okay. So that to me, if you did not know that your calculator did that, that's the admission for today. You can just check out, but don't check out because there's a drawing at the end and AP review material. Okay. So, very quickly, I'm going to do one more multiple choice question. And it is an inference one on, it's doing a 2-sample t-test for a difference in means. Now, going into this problem, the students need to understand and notice that this is multiple choice. If I look at my answer options for this question very quickly, they should recognize all this question is wanting them to do is run a stat test and come up with the p-value. They do not even need to read these statements at all. If you look in the parentheses, all of those intervals are all separate. So I'm a slow reader and I've learned tips to go fast. Oh my gosh, I just need to run a test and then get the p-value and figure out where it goes, and I'm done and I'm out of there. So now coming back to the question, they will need to recognize it's a 2-sample t-test for a difference of means. And so I'm going to clear this screen just so I have, again, a clear screen. Make sure students know where they run tests on their calculator. On the 84, it's stat, and then I move right over to tests. This is where tests and intervals are, okay? And make sure your students know when to use each of these, okay? I'm doing a 2-sample t-test, so it's option number 4. I do not have the original data to input, but if I turn this over to stats, that table they give me is all of the statistics for those 2 samples. I'm just going through and typing them in as quickly and carefully as I can. The only decision that I really have to make besides which test to run is, what am I seeking evidence for? And this is where, going back and reading the question, I'm trying to determine whether the 2 fertilizers give different yields. So it's nothing about greater than one being better than the other. It's just, are they different? So that's a does not equal to. Never change the default on the pooled. Calculate. There's my p-value. 0.016. I just need to figure out where is 0.016. Take my time doing that. These are all separate intervals. D. Again, I'm not even reading the statement. I just know my P is in D. I'm done. I'm out of here. There's that one. And double check, yes, I'm correct. I'm good. Okay. Our last question that we've got is a free response question. Take it away,
Tumbleweed.
Garrett.
Yes, I remember the tumbleweed. This is a recent one, and we chose this one because the calculator is really, really helpful here. For those of you who don't know the question by heart, it basically looked at these cochia plants in 2014 and in 2017, and they were concerned that over time they were becoming more resistant to an herbicide called glyphosate that was being used on them. There's a lot of tumbleweed in certain parts of the country, as some of you know. So in 2014, they randomly selected 61 cochia plants, and 19.7% of them were resistant to glyphosate. We took another random sample in 2017 of 52 cochia plants, and 38.5% of them were resistant to glyphosate. Then we have the traditional inference question. Do the data provide convincing evidence at a certain significance level, in this case 0.05, that there has been an increase in the proportion of all cochia plants that are resistant to glyphosate? So what I'm going to do here is I'm going to ask Tracy to let's go ahead and set up the calculator part, because we're going to show you the kind of traditional state plan do conclude kinds of things. But I'd like to go ahead and go to the stat test menu because we know we're going to do these calculations and that this is a calculator session. So let's do stat tests. This is going to be a 2 proportion z-test because we're looking at 2 different samples, and we're also looking at success failure, being resistant to glyphosate is a success. So we'll choose 2 prop z-test. In our first sample, well, we have to decide which one's going to be first. So right now it's going to be 2014 because that's the one I see first. And we need 0.197 times 61. If I could get Tracy to do that for me, 0.197 times 61. And that'll give me a non-whole number. Not good. We need 12. Calculator will not allow us to have a decimal there. It's the number of successes. And then our sample size was 61 for that year. And then for our second sample, 0.385 times 52. 0.385 times 52. I'm guessing it's going to give us a non-whole number. So we'll go back up and change that to 20 out of 52. And now we just need to figure out which way the inequality needs to go, because they're asking if there's an increase in the proportion of cochea plants that are resistant to glyphosate. Well, I did the first year first and the second year second. So that means the first year should be less than the second year if that's correct. So less than is the choice. Question about rounding. So we're trying to come up with the closest number in this case. It's not an up or down thing. We know that when people report results in questions on the exam or in the media, they often just round to the nearest whatever, 1/10 of a percent or whatever. So we want to go to the closest value. So we're going to come down and calculate. I want to show you this part because this is really the focus of this question. Calculator gives the students everything they need for the mechanics of the problem. So every student could write down that z-test statistic and that p-value and name 2 prop z-test. And if they just write down those 3 things, they've already got a point on the board in our 4-point scoring guidelines. Now they haven't checked conditions and stated hypotheses, but like they need to be able to get this point because as Tracy just showed you, it could have been a multiple choice question. That could have been like the whole thing. So we're going to use this to go through the slides quickly, just so you see. The first thing we'll do in a hypothesis test is we'll state our hypotheses. So I'm going to have Tracy just show that. So we'll state hypotheses, and then after we've stated our hypotheses, we're going to show our alpha level and name our procedure. Now the full name of the procedure is that long name. Students could certainly write 2 prop z-test. The exam question writers are not going to use 2 prop z-test. They're going to write the long name. So students do need to know the long name, 2 sample z-test for a difference in proportions. And then after we've done that, we need to check our conditions if we're doing the full procedure. So our conditions here, we need random something or other. In this case, independent random samples from the 2 years. We need to check the 10% condition because we sampled the cochea plants without replacement, and we need to check it for both samples. And then we need to check that it's okay to use a normal-based calculation with a z, and that's using our large counts. Unfortunately, we need to use that pooled proportion that shows over there in the calculator window of 0.283. The calculator just calls it p hat. On the formula sheet, it's p hat with a little subscript c for combined. So we're kind of combining these 2 samples together, and we use that number when we do our large counts check. Back in the old days, we kind of let it slide and we said, you could use just the observed counts of successes and failures for each sample. We've gotten a little stricter with the CED, and now they're supposed to use the sample size times the combined proportion and the sample size times 1 minus the combined proportion for both samples. Those are all at least 10, so we're good to go. Now we can show you the calculations that we already did. I'm not going to pretend to be that old school. I would just hit those buttons that Tracy hit. Even my students would be doing that. They're not required to write anything other than the test statistic and the p-value. So z equals 2.211. p-value 0.0135. There's the name of the test. So a student who literally just copied that calculator screen, we got that 1 point. And the final step, of course, we're going to need to show our conclusion, because the p-value is less than our alpha level. We reject the null, and then we have convincing statistical evidence. So we wanted you to know we know how to do these problems. We have to do our steps, whatever your steps are in your classroom. Those are all required for the full inference, but the power of the calculator is to guarantee everybody gets a point out of this problem, even if they have trouble with some of the other little minutiae there. Okay, Tracy.
Okay, so that brings us to our last slide, that if you need help with some review ideas, because you're getting close to that point, is our date's coming up close, and we're going to have that 30-day countdown pretty soon. So one thing I thought, if you enjoyed this webinar tonight and would like more of the same kind, which targeting using the calculator to get those students those extra little points here and there are previous webinars that TI has available on demand. So you can go to the TI site and go look at those previous webinars. There's a nice little filter that you can find statistics and even tailor it to whatever calculator you're using. A lot of the webinars, like I always try and show both calculator, at least the screens, but some of them might be targeted just one calculator or another. I also have a Google folder that has a slide in, which is a collection of review ideas. I created that like this slide for a TI webinar, and it literally just says, hey, try this, number 1, number 2, and lists a bunch of possibilities. So when you go to that tiny URL, that will get you to the folder. Look at the Google slide to kind of see what's all there. And that folder has all the files that you need. And I've updated it each year, added a few more things into it. Recently, StatsMedic has a blog post that's guiding you about planning for your review that I thought was really good. So I threw that on there. And then finally, the last but not least at all, we've got the AP daily practice sessions that will be coming on April 22nd. Darren, can you tell us about that pretty quickly? Because I think you know something about that.
I do know something about that. I can't tell you too much. Some of it's still, very quiet, but we hope you'll have your students take part. We'll be providing handouts for each of the sessions that the students can try the questions before they watch us walk through solutions. The idea is for them to practice and then watch us. Us is myself and Luke Wilcox. Those will be launched, all of them together on the same day on April 22nd. So we definitely would encourage you to use those with your students as a kind of last minute practice and reinforcement of the things they need for the exam.
And those are targeted towards students. This session was towards you. This is really directed to students. I've watched them in the past and thought I would spend my class period, get them to work, and then watch the video for the wrap up, because then they're hearing this information from somebody other than you, from an AP Stats legend or two, and hopefully they'll get enough information to get a few extra points here and there. I think we're going back to Mike, unless Darren's got something else.
Mike has something important.
Oh, yes.
Gotta give away some stuff. So tonight we are giving away to one lucky winner a graphic calculator of their choice, and tonight's lucky winner is Kenneth Brown. So Kenneth, congratulations. I'll be emailing you to get some information, but start thinking about which calculator you want to receive. To receive a certificate of attendance as well as a link for the documents for tonight, go ahead and click the link in the chat window. And if those links aren't working for any reason, just hang tight. You'll automatically get a follow-up email with those links, as well as a link to the recording, so you can go through this at your own pace. And if you're watching this on demand, you can copy that link into your favorite browser to receive your certificate. So we're going to skip to the end here. Huge thanks to Tracy and Darren for everything they put together and all the time they spent getting this material ready. Thanks for all the extra little tidbits and handouts and screenshots. It's really great. And thanks to everyone else for joining us. We hope to see you back online next week, where we'll be talking about IB exams. So if you want to learn more about IB exams, head to our website and register for next week's webinar. Thanks so much, everyone. Have a great night.